Hello students, how are you? कैसे क्या चल रही है? Welcome to my channel. If you have not subscribed the channel yet, please subscribe it. Today I shall discuss one important periodic properties, that is ionization potential. When energy is given to an electron, it gets excited. When the absorption of energy is continued, a stage comes when electron goes completely out of the influence of the nucleus and a cation is produced. Therefore, ionization potential can be defined as the amount of energy required to remove the most loosely bound electron or valency shell electron from an isolated gaseous atom to produce a cation is known as ionization potential. It is represented by the symbol I. It is represented by the symbol I/R/I.T. Ionization potential is measured in electron volt or kilocalorie. Its unit is electron volt or kilocalorie. The process by which the electron is removed from an atom is known as ionization. The process is known as ionization process. The process is called ionization process by which an electron is removed from an isolated gaseous atom. This is an endothermic process. This process is endothermic process since energy is absorbed in this process, therefore it is an endothermic process. Now we define successive ionization potential. Now we define successive ionization potential. Successive ionization potential. The electrons are removed from an isolated gaseous atom in stages. When the first electron is removed from an isolated gaseous atom, then the energy required is known as first ionization potential. For example, it is metal M and ionization potential is I1, then M plus electron. The energy required to remove first electron from an isolated gaseous atom is known as first ionization potential. Similarly, energy required to remove the second electron from a cation is known as second ionization potential, and the energy required to remove the third electron from a bipositive cation is known as third ionization potential. Similarly, we can define fourth ionization potential and so on. From here we can see that one electron is removed in each case, therefore I1, I2, I3 should be same, but this is not the case. I1, I2, I3 are not same. The following relationship have been found between I1, I2, I3, so on. The first ionization potential is lower than the second ionization potential, which is lower than the third ionization potential. This is due to fact that it is relatively easier to remove an electron from an unipositive charge cation than to remove an electron from a bipositive cation. Or we can say that it is harder to remove an electron from a cation having higher positive charge than a cation having lower positive charge or isolated gaseous atom. Thus, first ionization potential is less than second ionization potential, which is less than third ionization potential. Next, I shall define about the factors affecting the values of ionization potential. What are the factors? The factors affecting the magnitude of ionization potential and its periodic variation. What are the factors which affect the magnitude of ionization potential and what is its periodic variation? The first thing in this topic is charge, nuclear charge. First thing is nuclear charge or charge on the nucleus. Charge on the nucleus. It has been found that with the increase of nuclear charge, the ionization potential increases. This is due to the fact that with the increase of nuclear charge, the electrostatic attraction between the nucleus and valence shell electron increases. Therefore, it becomes harder to remove an electron. Thus, the ionization potential increases. For example, if we take second period, then we can see that ionization potential increases from lithium to neon. The nuclear charge increases from lithium to neon 3, 5, 7, 9, 10. Therefore, the attractive force increases. Thus, the ionization potential also increases when we move left to right in second period. The second factor is, first factor is nuclear charge. The second factor is degree of penetration. The degree of penetration of electrons. The degree of penetration of electrons increases in this order. S electron can penetrate more closely to the nucleus than P electron, and P electron can approach more closely than D electron. Therefore, if an electron is removed from S orbital, then it will require more energy than the P orbital electron. Thus, the ionization potential in case of S electron will be higher than the ionization potential in case of P orbital electron. So, the second factor is degree of penetration. With the increase of degree of penetration, the ionization potential increases. S electron, the atom having valence shell electron in S orbital will have higher ionization potential than the P electron. The third factor is completely filled and half filled orbitals. Completely filled and half filled orbitals. The third factor affecting the magnitude of ionization potential is completely filled and half filled orbitals concept. From Hund's rule, we know that completely filled and half filled orbitals are more stable. Therefore, in case of completely filled or half filled orbital electrons, the ionization potential is relatively higher than expected from its position in periodic table. For example, if we take second period, in second period beryllium and nitrogen, in case of beryllium, atomic number is 4, its electronic configuration is 1s2, 2s2. Here the valence shell is completely filled, 2s is completely filled, therefore it will be more stable and some more energy will be required to remove the valence shell S electron. Similarly, in case of nitrogen, the configuration is 1s2, 2s2, 2p3. Here 2p orbital is half filled, therefore it will be more stable. So relatively more energy will be required to remove the valency shell p electron. Thus, the ionization potential of beryllium and nitrogen will be relatively higher than expected from its position in periodic table. Similarly, in case of third period, magnesium and phosphorus have relatively higher ionization potential. So the third factor is completely filled and half filled orbitals. Now the fourth factor affecting the magnitude of ionization potential is screening effect. This is known as screening effect. Screening effect of inner shell electrons. For example, if we take the nucleus having Z positive charge, and these are the inner shell electrons, and here is valency shell electron. It is valency shell electron. Then there will be attraction or attractive force. There will be attraction or attractive force between the nucleus and valency shell electron. Similarly, there will be repulsion. There will be repulsion or repulsive force between inner shell electron and valency electron. The net effect of these two attractive and repulsive forces is that the attractive force between the nucleus and valency shell electron gets reduced by the inner shell electron due to the repulsive force of the inner shell electrons. Thus, with the increase of number of inner cells, the ionization potential decreases. This is due to the fact that with the increase of inner cells, the net attractive force between the nucleus, this is the nucleus, the net attractive force between the nucleus and valency electron, this is the valency electron decreases, therefore it becomes easier to remove an electron from its valency shell. For example, if we take second A group elements, beryllium, magnesium, calcium, strontium, then the number of inner cells increases 1, 2, 3, 4. Therefore, the net attractive force goes on decreasing. Therefore, the ionization potential decreases. Beryllium has ionization potential 9.3 electron volt, but strontium has ionization potential 5.7 electron volt. So, fourth factor is spinning effect of inner shell electron. Due to this effect, the ionization potential decreases when we move down a group. Now, the fifth factor is atomic size. Fifth factor is atomic size. With the increase of atomic size, the distance between the nucleus and valency shell electron increases. Therefore, the electrostatic force of attraction decreases. Thus, it becomes easier to remove an valency shell electron, and thus ionization potential decreases. For example, if we take first A group, lithium, sodium, potassium, rubidium, alkali metals, then ionization potential decreases from moving downwards from lithium to rubidium. This is due to fact that the atomic size increases from lithium to sodium, the number of cells increases, therefore the distance. For example, lithium has 1s2, 2s1, and sodium has atomic number 11, 1s2, 2s2, 2p6, 3s1. Here the valency shell electron is in the second cell, but in case of sodium, valency shell electron is present in third shell. Therefore, the distance between the nucleus and valency shell electron increases. Therefore, attractive force, electrostatic force of attraction decreases. It becomes easier to remove the valency shell electron. Thus, the ionization potential decreases down the group. The fifth factor is principal quantum number. Sixth factor is principal quantum number. Principal quantum number. N. With the increase of principal quantum number, n is equal to 1, 2, 3, 4. The distance between the nucleus and valency shell electron increases. Therefore, the attractive force decreases. Thus, it becomes easier to remove the valency shell electron. Therefore, the ionization potential decreases. Thus, we can see that with the increase of principal quantum number, the ionization potential decreases. So, today I have discussed about ionization potential and the factors affecting the magnitude of ionization potential. There are 6 factors which affect the magnitude of ionization potential. The first factor is nuclear charge or charge on the nucleus. With the increase of nuclear charge in a period, the ionization potential increases. It is due to the increase in attractive force. The second factor is degree of penetration. With the increase of degree of penetration, the ionization potential increases. The third factor is completely filled and half-filled orbitals. According to Hoold's rule, completely filled and half-filled orbitals are relatively more stable. Therefore, in this case, the ionization potential is relatively higher than expected from the position of the element in the periodic table. The next factor is screening effect of inner cells. With the increase of inner cells, screening effect increases. Therefore, the net attractive force of nucleus on valency shell electron decreases. Therefore, ionization potential decreases. The next factor is atomic size. With the increase of atomic size, the electrostatic force of attraction decreases. Therefore, the ionization potential decreases. Similarly, with the increase of principal quantum number, ionization potential decreases. So, today I have discussed about ionization potential and its width and its variation in a group and period in periodic table, and the factors affecting the magnitude of ionization potential. Thank you for watching my channel. If you have not subscribed yet, please subscribe it. बहुत लोग देख रहे हैं लेकिन चैनल को सब्सक्राइब नहीं कर रहे हैं. Please subscribe it. Your comments are welcome. If you have any query in this lecture, you can write in the comment box. Thank you.